So now I would like to introduce Jim Reuter, the Associate Administrator for Space Technology, who will dive a little deeper into some of these technology investments and what we're really doing to try to make this a reality. Welcome, Jim.
Yeah, thank you, Rachel, and thank everyone for joining us here today and for the next 2 days. I'm really excited and looking forward to it. I'll say it's a privilege to have Bob as the person I work for, and it's a joy, and I can't say enough about that. And I want to thank APL for running the consortium so effectively and hosting today, Bobby and Jason and so on. And if I remember right, I was here just a couple weeks ago, and Bob talked about that astronaut class. And I think there's one from APL on that class, and even a LSIC member, Andre. So right here among us, you all could be astronauts in the next class. So let's see. Oh, I do have charts. Is it possible for me to just say advance, and then I don't have to try to work this button that didn't seem to work that well? So what I thought I'd do is just talk a little bit about what's going on now. As part of our what we call Space Tech, the Space Technology Mission Directorate, and kind of go through a few things, and hopefully it'll be of interest. Next chart, please. What I'd say is, for space technology, we pride ourselves for having a very broad distribution of programs and stuff. We address things from all the way from low technology readiness level, that's concepts in the lab, to the laboratory material level, to flying things. We have something like 1,500 projects or so as part of our portfolio that are active, about 400 or 500 university partnerships that we go through it, and about 140 things or so we're taking to flight. What we have done is, in order to try to help guide our investments, is we've developed what we call a strategic technology framework for what we have there. And I just introduced a little bit because actually tomorrow, when a lot of the sessions tomorrow is kind of going to get at this for a discussion. But for us then, what we've done as part of that framework, we have 3 leadership tenets, if you will. The first one is to ensure American global leadership in space technology. So, the developments that we do, that are technologies that advance forward, that are cross-cutting, that all leads towards ensuring our global leadership. The second one is driving the space economy. We know that we believe technology is what drives that economy, and it's a key part of what we do. So it's a key part of why we're all here today, too. And then finally, to inspire. And to really, a big part of what we do is to inspire. In fact, I would say one of the key things that, in order to ensure the sustained presence on the moon that Bob talked about, is we have to have inspired and engaged the entire community. If this is something that's in a couple of regions of the country, or if it's something that is kind of limited to what its scope is, then we won't get there, I don't think, and be able to stay. We'll get there, but we won't necessarily stay. So those 3 tenets are for leadership. Then what we've done is develop 4 strategic thrusts that guide our investments, and those are listed at the top there: rapid, safe, and efficient space transportation, which we call GO; expanded access to diverse surface destinations, which we call LAND; sustainable living and working farther from Earth, which we call LIVE; and then transformative missions and discoveries, which we call EXPLORE. So if you want to know what our strategic plan is for investments, it's GO, LAND, LIVE, EXPLORE. And you'll hear more about that this afternoon. So then what we did is we've developed these mission objectives or strategic objectives that go with each of those thrusts. There's 17 or so of these objectives, and they're what's guide our investment strategy. For those objectives, then we've gone through and identified what are the key capabilities that we need in order to meet those objectives. And they're sitting there in those circles around there. Those are kind of those key 13 or 14 capabilities that we need. And then from that, we've had our folks develop what we call envision future priorities and stuff. And I'll talk about that a little bit more than Walt tomorrow. We'll talk about it quite a bit, and the folks that we'll talk about it quite a bit more tomorrow as we go through it. So anyways, those objectives then map to what the agency is collecting in terms of objectives for blueprint objectives, I think is what we call them. And those are getting developed, and we're in straight in sync of those parts of our portfolio, at least, that also support Artemis. And then the final thing I'll say is, is then there's that big chunk there on blue. As Bob talked about, there's a lot of technologies that we can demonstrate and capabilities that we demonstrate on the moon that feed forward to us going to other planets, specifically Mars for the nearer term. And those technologies are things that are part of this Lunar Surface Innovation Consortium. And we'll be talking about that as the time goes on. Next chart, please. Bob showed this chart, or at least a very similar version for it. He talked about intuitive machines. Well, I was just at Astrobotic a couple weeks ago, and they unveiled their Peregrine lander. That was really exciting to see. It was the kind of first, I think, of the unveilings, and it just shows the diversity of the capabilities that industry has developed, the commercial space has developed, that is really being helped by the Commercial Lunar Payload Services, or the CLPS program. And for us, that intuitive machines that Bob talked about with Steve Ultimus, the IM2 machine is basically a technology demonstration mission. And we have on there the first use of the Prime 1, the drill that searches for water. That same drill will be, and mass spectrometer will then be used on the Viper mission and be mobile about it. But so we'll have an early demonstration of that. We also have a 4G LTE network demonstration that Nokia has offered. And then also a lunar hopper. Basically, if you try to extend your reach, this would be a small hopper that can go about a mile at a time, between hops along the lunar surface and stuff. And you can imagine then hopping down into a crater, hopping back out, and that sort of thing is the intent. We have overall about 25 or so flight demonstrations right now as we go forward. But I'll also say is we're actually in an evaluation period. It's something I meant to say in the other chart. I just wanted to talk briefly about our budget, because some of you at least have heard about that. First of all, we have our budget for space technology in FY22 is $1.1 billion, which is a very strong budget, I believe. You can do an awful lot with that when you're dealing with technology items. We're really excited to have that budget. And we're even more excited about the FY23 President's budget request, which is about 30% more than that or something. It shows a real dedication, and you heard it yesterday with Bill Nelson's testimony, and Bob mentioned it this morning. There's a real push towards understanding that we've got to fund our technology programs in order for us to proceed. Now, so the downside of that, of course, it's a request. Our appropriations for FY22 is good. It was 1.1 billion, but it also is flat. We've had the same budget now for 3 straight years, 2 years in a row of flat budgets, and it does mean that we're right now going to be being very careful of what we have, and we won't be able to advance some of the things that we wanted, including a couple of the demonstrations we'll have on the moon are very likely to go that way. So I just wanted to at least address it up front, but what we're also optimistic about the strong support that's out there, it really in all our stakeholders as well. It's just there's tough decisions that have to be made. And we're excited about where that will go here in FY23. Next chart. It's my pleasure to talk about one of our challenges, because we actually have an announcement to make of our winners for this. We started, it was 2 years ago, we started a challenge that we called Honey, I Shrunk the NASA Payload. And the idea behind that is, I mentioned the hopper, and there's also multiple places where little rovers are being there. So what we wanted to do is find payloads that would go on one of those platforms and stuff. And so to do so, you need to be about the size of a extra thick bar of soap. The lander itself, these are little rovers that are about the size of a Roomba and stuff. So, but it's amazing what people were able to do and create, and we want to just get creative and see what they could do. And so the idea behind this challenge was to seek out creative approaches to developing miniature payloads to collect information on the lunar environment and resources. Beyond that, it was pretty wide open. And you can see there's 3 winners that we had. Actually, when we went through there's been 2 phases and a couple of stages or something. I've kind of lost track, but we received originally 132 submissions from 29 different countries with ideas for this. We awarded to the top 14 teams about $1 million worth of prize money. And then from there, we asked I think 3 or 4 of them, well, there's 14 or so that went on, and we narrowed it down to 3 that became our winners that we're just announcing now, and it'll be published in about 20 minutes. So anyways, those 3 winners are Sun Slicer. It's X-ray spectrometer. You can read the words about as well as I do, but the idea behind using the solar corona to help detect elements and stuff is pretty cool. That's the first prize winner. The Pooley water snooper identifies hydrogen and hydrogen-bearing volatiles. I've never heard water talked about as being a hydrogen-bearing volatile before, but it's a new definition to me. But anyways, so it measures quantity and distributions. And then the microrad is radiation demonstration. So we're really excited, and I'd like to ask you to give them a round of applause for the 3 winners that we have that we're going to try to fly. Okay, thank you. Could I have the next chart, please? All right, I have 2 charts. I just want to talk about a couple of things that are going on right now within space technology over the next a few months and stuff. First of all, we have this, what we call a capstone lunar CubeSat. Well, we call it a CubeSat because it officially is 12U size or something like that. But you know what? A 12U size thing is a small sat. You know, and especially when you put those arrays and stuff. But the idea behind capstone was one we had back in mid-2019. We said, well, we're going to go to this halo orbit. The near rectilinear halo orbit with a gateway. We said we've never actually operated in that. Why don't we take a small a CubeSat and just see if we go to there first and demonstrate the capabilities of going into and out of this orbit, that sort of stuff, demonstrate and here some autonomous navigation on a very small satellite and some other things. And so Advanced Space has led this mission for us, doing a great job. And we're just about ready to fly. It should be in the next few weeks. Or something that if you look, we'll be launching out of New Zealand, and there'll be the first entry into that orbit, and help guide us. And so we're really excited about that. I had the privilege of going out to Advanced Space, and they're in Colorado in the Denver area for ribbon cutting for their operations center, because a lot of these places, that's the other thing that's kind of cool about these small business operators, the coach, and these folks, is their operations centers are right there with where they work. The other demonstration we have is coming up in, let's see, it's this fall now. It is timing for what we call the lofted flight demonstration. The idea behind this is one of the key technologies that would help us land humans on the moon or in large payloads. I'm sorry, on Mars, not the moon, and have or potentially used for large payloads on Earth. This is a pure, true public-private partnership. We do not exchange any funds with ULA, but they are a key part of this demonstration with the flight. It's a ride share for one of their flights. It's the JPSS-2 mission as we go through it. And the idea behind it is you need to, with the atmosphere of Mars being so thin, but there, existent, you need it. It's kind of the anti-Goldilocks atmosphere, because it's not thick enough to help you slow down, but it's too thick. But it is too thick, so it causes you some issues. And so the idea is get a big drag area. How do you get a big drag area? And is one way is to inflate. And so the idea behind this is this is a demonstration in Earth atmosphere, which we can simulate the conditions for a Mars return, and then it inflates. This is a 6-meter diameter demonstration of the technology, and we'll watch it land and stuff here this fall. In order to land the 20 metric tons or so that we need for the moon, from Mars, it needs to be about 15 meters and something. So, but this is a great first step. It also is a potential for returning large mass to Earth and stuff. So that's why it's there. So we're looking forward to that, and the JPSS-2 mission is sometime now this fall. Next chart. 2 optical communications demos that we have also. The laser communications relay demonstration on the left is something that launched in December. And on the STP-6 satellite of the STP-3 mission for U.S. Space Force. And so the idea behind this is we'll be demonstrating bidirectional optical communications between the spacecraft in geo orbit and the ground in a couple different ground stations. and just demonstrate that capability and usability of that sort of capability. And so we're looking for that, forward to that. It has completed now the checkout. It's very successfully, and we're getting into the experiment phase, which is expected to last a couple of years is our goal target. And then also the deep space optical communications is an optical comm that we have manifested on the LSIC mission for SMD's mission to the asteroid belt. Along the way, so it gives us the capability to demonstrate a very from deep space communications, optical communications to all the way to the ground from the spacecraft. And so it's a complementary spacecraft compared with LCRD, one's in GEO and one's in deep space. And that mission is on track for early August launch. And our DSOC item is integrated into the vehicle now as we speak. And so we're looking forward to that mission. Next chart. Then this is something we want to reach out to the audience here and gain input as we go forward. This will be the subject of some of the discussions tomorrow. But I just want to talk about it a little bit. Is we did, as I said, we have this Go, Land, Live, Explore basic framework of what our technologies are. We've been developing, and as I said, tomorrow there'll be a lot more discussion on envision futures. And so with those, the idea is we're trying to document in a small package what's the state of the art as we understand it, what do we think the needs are, and what are some technology gaps. We've released, then with these 4 different strategic thrusts, we're releasing requests for information for industry or for anyone out there that wants to comment to it. And we're looking for your help in improving our product and giving us your perspective. So we did release the Go back on April 7th with the responses due May 20th. The Live, we're releasing here within the next couple of weeks or so. And so we're kind of previewing them tomorrow for several of them, not all of them, that's in that category. And then Land and Explore, we plan to do both together in August, September timeframe. And then that will lead towards the Ascend conferences in October, and we've worked out with AAA that our intent will be to kind of present all these things at that forum as we go forward. So, and next chart. And then my last chart is funding opportunities. I'll just mention some of these right now. We mentioned the Tipping Point. We also have a sister program to Tipping Point, which is called the Announcement of Collaboration Opportunity. The main difference is that with the ACO, that we call it, is no exchange of funds with whoever's there, but we do provide technical expertise. Tipping Point, we can exchange funds. This is a 2-stage process that we go through. First of all, we seek ideas and preliminary proposals. We pick the ones that we want to further have as full proposals, and then we go through that. So right now we've received those preliminary proposals and we've begun the review of those. And I'll say that the response was tremendous. It's something like over 250 proposals that we received. That second line that's really long, well, that's our tech flights program. Suborbital things is traditionally what we do for suborbital payloads and stuff. We typically we have about 60 or so flights per year of payloads, stuff like that. So anyways, this year though, we've combined it with some orbital flight opportunities for low cost. And so we've broadened that there. And so responses are due in June, and I think it's July or something like that is when the proposals will be due. The Watts on the Moon Challenge Phase 2 is open, registering by June 15th. And it's not on this chart, but we just had a discussion yesterday on Break the Ice Phase 2. And so that's not on our chart, but it is something we're planning on releasing probably in the summer timeframe as well. Early stage innovations is our space tech research grants, one of the top ones we have there. Those we've just released those topics, and the notice of intent is due by May 25th. Our Space Tech Research Institutes, these are something we do every other year. There's 3 universities at least that have to have 15% stake in the proposal they have. For us, what we do is we give topics that are fairly broad, but are focused, but pretty open of what they want to do with them. And so the idea behind those is we pick a couple topics and then we'll go out for proposal reviews. It's also a 2-step process as we go through it. And then the NIAC, one of our favorite programs for really, as long as you don't break the laws of physics and you have a revolutionary idea that could serve a mission, then it's fair game. and it has to be revolutionary to have you score well. That phase 1 opens in June. And then our space technology graduate research opportunities, which are for our grad students and stuff, opens again. It's annual and opens in September. So with that, it's a pleasure for me to be here, and I really look forward to the next 2 days. Thank you.
All right, we're about to take a break, but do you mind answering one quick question?
That's fine, sure.
Okay, so we have one that asks, when are the tipping point selections expected to be announced?
Yeah, when the tipping point selections are expected to be announced, it kind of comes back to that budget thing that I talked about. And so what we've done is we originally were thinking we'd do it a little faster, but as it became apparent where our budget could potentially head, we put off the solicitation so that we're timing it so that it'd be an FY23 dollars as stuff. And so right now, by a nominal timeline, in that first quarter of the FY is when we could announce. We're also going to have to see where we think our budget will be. And so we'll make that decision later on. But what we're going to do is proceed ahead, with the timeline we're on right now, with the idea of this fall, we could, late fall, we can make the announcements, but we'll just see how it looks.
Okay, thank you very much. So with